Okay, we have the matrix A equals 2, 4, 3, negative 2. I don't need to read that to you. Right there it is. And we want to find the inverse of A. Now, we already know how to find the inverse of a 2 by 2. We find the determinant, this times this minus this times this. And then we reverse these two and make these two negative and divide everything by the determinant. Then we get the inverse. Okay? But that only works for 2 by 2s. What I'm showing you here will work for any dimension matrix, any n by n matrix, 3 by 3, 8 by 8, 47 by 47, whatever. Now, I'm demonstrating it for a 2 by 2 matrix because there are a lot of steps if you do a big matrix. And we can understand what is done just by understanding what we do with a 2 by 2 matrix. So, what we do is we augment the matrix. Whatever the matrix A is, we augment it with the identity matrix of the same size. So if we have a 47 by 47 matrix here, we do a 47 by 47 identity matrix here. Okay? Well, we augment it, so we do that. We augment this matrix, the A matrix, with the 2 by 2 identity matrix. One's in the diagonals, 0 above and below the diagonal. Then, all we have to do to get the inverse, and it's not a trivial thing, but it's not a difficult process to understand if you know how to reduce a matrix, and I hope everybody does by now. You reduce this matrix to the identity, whatever steps take, whatever row operations we need to reduce this matrix to the identity, we conduct those operations. Okay? Then the matrix that appears over here as a result of that is going to be the inverse. And this is the I matrix augmented by B, the inverse. So how does that work here? Well, we take half of the first row. Remembering to take half of everything, some people are forgetting to take half of whatever follows this, whatever is augmented. So don't forget that. The whole first row by 1/2. Then we add negative 3 times the first row to the second, giving us the 0 that we want here. Then what do we want? We want a 1 here, right? So how do we get that? Well, we got the 0 here. We divide by negative 8 or multiply by negative 1/8, whichever way we want to think about it. And we get our 1. Then, of course, everything follows on the other side. I'm not going to read it to you. You should know how to do this by now. If you don't, review. Go back to previous videos, get on the internet and search out reducing augmented matrices, reduce Jordan form, whatever. Okay, so here we have it, and now we just need to get a 0 here, so we add negative 2 times this row to this one, and what we end up with here is our B matrix, our inverse of, that's going to be the inverse of A. Now we're going to verify that it's the inverse of A. So it's a little hard to read here, you know, that 1/16 there didn't come out very well, but there are little glitches on the board, and okay, B is this matrix. How do we verify that's the inverse? We multiply A times B. And we should also multiply B times A to be sure, but if it works one way, it'll work the other. Okay, so A times B, there's A, there's B. We do the multiplication. I'm not going to read it to you. You can do that multiplication. And you can verify that we get the identity. So B is the inverse of A. So we say A and B are inverses. Verifying, at least for this example, that the process worked. Now to prove it and to prove that it works in general for any size matrix, yeah, that's a little more work, but it isn't really that difficult. Okay, so here we have that.